Hi. Well, this is a little bit different. I'm just getting over a cold, so my voice is a little rough. Um, so I've been thinking about dark matter and sort of pondering what really this means. Okay, um, and basically it blows everything away. Um, it means things such as um, well, I sort of hinted at the possibility that photons would travel through space without their wave function. And in fact, all of the experimentation we've done on Earth has been in this background of dark matter. So even everything we know, even of gravity, now this is where it gets weird, but basically even gravity has been done in this dark matter soup, or whatever you want to call it. So if you think perhaps that such things as relativity, which was Einstein got his ideas based on the fact that the speed of light was the same in all directions, okay, and that's maybe affected by the presence of dark matter. So it means that perhaps everything, our understanding, and perhaps even down as far as the quantum probabilities, are related to dark matter. So, okay, if we take the idea that, say, a graviton or a Higgs particle or whatever you want to call it requires a field, but in fact there are no such things as fields. There are only such things as particles, and the forces that we say are forces are just different type of particles. Then perhaps, if that's the case, in true space where there would be no dark matter, perhaps there's no fields. Perhaps, well, perhaps you couldn't have an electrical field. Maybe you couldn't have a gravitational field. That's sort of where it gets down to, is perhaps gravity works in galaxies and planets and all the things that we do, but perhaps gravity doesn't work if two sort of we want to call them Higgs particle fields aren't in contact. Perhaps other galaxies are just free-floating structures, and it's only, say, when they sort of bump into one another. When they bump into one another, of course, now all of a sudden their fields, like almost like bubbles touching, snap together, and now you have a huge thing is going to happen. You're going to have all of that energy just going to be, you're going to have, quasars. That's what you're going to have. Basically, quasars are going to be the proof that there is no gravity between galaxies. There's gravity in planets, there's gravity in Milky Way, etc., etc. But once you get beyond dark matter, there will not be gravity. But that doesn't mean that something, so if you throw a particle out, it's still going to follow exactly the same laws of inertia. So the photon, when it exits the dark matter, continues to go in the direction it was going. And all same with every other piece of matter, okay? But what it means, though, is that a stable universe is probably the rule. That our galaxy is not orbiting around another cluster unless the clusters have somehow touched their Higgs fields together. Their dark matters touched each other, and then basically then they would be forced into gravitational attraction, and then they would start to orbit one another. Okay, but if our Higgs field didn't touch another Higgs field, we would just float on by. Okay, and it's possible that, let's say, if one galaxy was to go into collision with another, that it would slip right through with all of the collisions, etc., etc. But if the velocities were high enough, that it would slip right through and sort of go off on the other side, pulling with it its portion of the dark matter, and leaving the rest with the galaxy that it went through. I know this is even more radical than the redshift stuff, and I apologize for sort of throwing this out there, but I just think that perhaps we really we won't even scratch the surface. Like, this is just, for me, it's mind-boggling. I wonder if I'm going crazy.